Okay, so this is Introduction to Statistical Learning, Chapter 11, which deals with survival analysis. And we are on question 11, which is the final applied question. So this example makes use of the data in this table right here. And so we will put this into code. It's just a small table with just looks like 6 data points. And we'll look at the, well, let's just get a little bit familiar with this. So we have the observation y, right? So the time of something happening, and then a censoring indicator. So whether that something happening was an event or a censoring event. And then a covariate here, x. So it's some predictor variable that we will try to, well, at least at one point, try to use in order to predict y. I'm just going to click this down here because it takes a second for these packages to load up. Okay, so right now we are installing the survival package, and that will take just a second. And in this first part here, I am just creating this table right here in R, right? And I'm just calling it D, right? So we have y, delta, x. Hopefully I've put all of those in correctly. All right. So now for part A, we're going to create 2 groups of observations. Group 1 is where the predictor variable x is less than 2, and group 2 is where x is greater than or equal to 2. And then we're going to plot Kaplan-Meier survival curves corresponding to the 2 groups, making sure that we label and we want to say, does one appear to be different than the other? Okay, so everything's finished loading. We have our data table right here. That should just be replicating what we had up here. Okay, so we're going to create our 2 groups first. So to the data frame, D, I'm just going to add group, and group is going to be G1 if x is less than 2, and G2 if x is 2 or greater. Okay, hope I said that right. Okay, so now we have D, and now we just have the additional group here, right? So you see that according to x, if x is less than 2, we have G1. Here, 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 and if it's greater or equal to 2, such as here and here, we have group 2. Okay. And now we want to plot the survival curves according to group. So I'm going to run. So I'm calling this fit-serve G for group, and I'm going to regress on group here. And then I will just plot the lines, okay? So I'm going to plot this, so plot fit serve and now we have the 2 lines here, okay? And group 1 is in blue, group 2 is in red, and we're supposed to say, you know, do these look the same? Do these look different? Well, it's a little bit hard because they have a different number of events. So they certainly don't, you know, they're certainly not identical, but without you know, error bars and those types of things, it's a little bit hard to determine. I try to do this with error bars, and it just becomes very ugly, and so I've just left them off here. But I think that the conclusion we're supposed to reach is that they don't really look that different. The error bars are completely overlapping, which is not that surprising since we only have 6 data points. The error bars are rather large. Okay. Now part B. We want to fit a Cox proportional hazard model using the group as an indicator of the group indicator as a covariate, and then we want to look at the coefficient, the estimated coefficient for group. In other words, how is group? I want to say affecting, but you know, how does it correspond to the hazard value given? Okay. So we run Cox PH, just kind of like we did above, and we'll look at the summary here. And so when we do it like this, we get that the coefficient for group. So notice it says for group G2. That's because G1 is the reference, right? So if we wanted G1, we would just reverse the negative sign here, and then G2 would be the reference. But this says okay. So our estimated coefficient is negative 0.3401. Okay. So this means that group 2, in other words, when x is greater than or equal to 2, they have a lower hazard than group 1. And we can get a little bit more precise. So if we exponentiate that value, we get 0.7117. Okay, so that means that group 2 has a hazard that is, 71.17% compared to group 1. Okay, however, so that's according to the estimated coefficient. But if you look at the size of the standard error as well as the p-value, you recognize that this is not a significant difference, which again, we can kind of tell by eye here, especially if you imagine that there's large error bars here. Okay. Oh, and well, also this right here is not a Cox proportional hazard model, but they correspond to one another. So I don't mean to say that the graph represents that analysis, but it's not surprising that they both lead to a similar conclusion. How about that? Okay. Now, part C. So, in the chapter, in section 11.5.2, you can go back and reread it, and it shows that with a single binary covariate, the log rank test is identical to the Cox proportional hazard test. And so we're just going to look at the estimated statistic and p-value for those two tests. You can look at how I've done this here, but it's just going to make a table with the final statistic as well as the p-value for the log rank test as well as the Cox model, and as you will see, they are identical in both cases. So, okay, that concludes the chapter 11 on survival analysis. And I think that the next chapter is on unsupervised learning methods, which is kind of interesting. And that will be the second to last chapter. So, all right, I will see you then.